Welcome. I'm Naga and I'm excited to showcase our GenAI intensive course capstone project. It's called Watt-Seer Compare, which we have developed with teammates Harshita, Praveen, and myself, Naga, with the help of our mentor, Suresh. In this presentation, I will explain to you what we have done and walk you through the code and also show some insights that we can get from this project of what we called finding your household's energy twin. So the problem that we wanted to address is this. So maybe you are in this situation where you got a lot of numbers of kilowatt hours, but what does that actually mean? So these are all raw numbers, right? And maybe you were wondering like, okay, how does it compare to home like yours? Most of us don't know whether we are energy efficient or wasteful, wasting the energy. Is this a normal bill or not? So this lack of context keeps people in the dark. And this is what we wanted to address by this project. Introducing Watt-Seer-Compare, a personalized energy benchmarking tool powered by GenAI that helps finding your energy twins. So what we mean by finding your energy twin is it compares your home to similar homes based on smart meter data, usage patterns, weather, appliance types, and household size. Then it translates this data into natural human-friendly explanations. So this is what we will walk you through in the coming slides. So here you see one example where, for example, you are a target home number 66, and here on the x-axis you see different appliance types: air conditioning, lights, computer, TV, and dishwasher. And the blue ones are your target home, which can be your home. And then the average of other homes, we can here in this example we have shown similar 5, but in the later ones and in the code base we show similar 10, but the concept is similar, where we compare with other similar bottom or top similar houses, and then we can compare, okay, how is it trading between your house with respect to the similar houses. And this is where you can see how are you energy efficient or not so energy efficient. And this is one other plot where you can get a total energy consumption of a particular month, and then how you are faring with respect to yours and with your peers. So with your peers, meaning your energy twins, they need not be in exact neighborhood kind of, but then they have the similar profile. And that is what we mean by energy twins here. So what data did we analyze in the project? So what we have used is something called smart home energy data. This is the data that we have analyzed, and each row has these components: home ID, as you see in the bottom table as well. It's a unique number from 1 to 500. Appliance type, either fridge, oven, dishwasher, heater, microwave, and so on. What is energy consumption in kilowatt hours? What time and date was this recording done? What is the outdoor temperature? What is the season? Because the season also influences a lot the heating and so on. Household size, which is a major factor in demand as well. And then these are the two derived parameters that we have done based on the date and time and the year on month. We have derived these two parameters for subsequent analysis. And this is the data that we will crunch, and we will pre-process this and then go to the next steps. So next, we want to show you what is our solution, what are the main steps that we have taken, so that we can go in detail in the coming slides. So here what you see is our solution, where it transforms the raw energy that you saw before into meaningful insights. And what are the steps that we have taken here? So the first step that you see here is that first we pre-process and summarize the monthly energy usage per home. And this is given to the next step, where we encode those summaries using Google Gemini's embeddings, turning descriptions of those summaries into numerical fingerprints. The third step here is from a vector space that we have, vector space of embeddings that we have, we retrieve these embeddings using cosine similarity to find homes with similar energy behavior. And finally, we use Google Gemini's LLM generation capabilities with chain of thought prompting to analyze and explain the similarities and also differences between households in a natural language so that anybody can understand. And here we have used long context. We have utilized the long context that Gemini models offer, which was really important as well for this analysis. So the model critically analyzes multiple home profiles and synthesizes insights that would take an energy analyst probably hours to produce. So these are the four main steps. Also, there is a important thing that in these steps that we have, it is sort of a lightweight RAG solution as well that we have embedded into this. And this is what you will see in the next coming slides as well. So next, I will show you each of those some steps kind of, and what is the output of the step, and then show you what concepts we have used from the GenAI course that we have taken. So this is the first step where we create monthly summaries. So we have the data that we have, and then so the data, for example, is the home ID, year, month, average temperature, and so on. And then we create a summary text as you see here. So the code snippet is shown on the right, and the one of the main important thing in the code snippet is this summary text that we create. And then based on this summary text, what we get essentially is distilling energy data into monthly summaries, turning numbers into stories. This is what is the first step that we have done. Then this input of monthly summaries is given to the second step, which uses Gemini's embedding models. So here you see a function called generate embeddings efficiently. So this function converts the textual summaries of household energy usage into dense vector representations, which is embeddings. And these vectors allow the system to reason with semantic similarity. So this is the semantic similarity task type that we have used in this particular one, which is a really important one. And through these ones, through these semantic similarities and so on, and embeddings, we can turn the summaries into vector fingerprints, which can be ready for comparison. One other thing I would like to highlight is that we have used batch embeddings here. This is very important because of the number of rows that we had. We have to process this and make the embeddings in a batch fashion. And a snippet here is what is the concept that we have used, and then what it does, and this step is used to do what. And this is how I show you in the next slides as well. So the concept that we have used here is text embedding 004. And what it does is this step converts the Google Gemini's embeddings into textual summaries. And this is really important, as I mentioned already earlier. And this step is used to whatever we have in the summaries here, kind of the one that I showed you before, are converted into a high dimensional vector spaces, which is the key to compare similar homes. So now this is the third step. The input from the previous step now gets into this step here. And here the magic of cosine similarity comes in. So the cosine similarity finds the mathematical closeness between the embeddings that we have created in the previous step to identify your true energy twins based on a comprehensive usage patterns rather than just simple filtering. So the concept that we have used is the vector comparison in the embedding space, and it does compute the cosine similarity between top k similar and bottom k list homes, and then this builds up a similarity based neighborhood. So this concept was used to find the energy twins and create n comparisons. And here I would like to point out that this step of cosine similarity that retrieves the n most similar homes can also be seen as the retrieval part of the RAG solution. So this is a lightweight kind of retrieval part of the RAG solution, as I mentioned before. Now, finally, that information, whatever we have generated previously and the embeddings and so on, now we have to feed it into we can feed it into a LLM. And here, this is important step as well, because we have to generate a human-friendly comparison narratives. So here we have used Gemini 2.0 Flash, and we have used a chain of thought prompts. And here you can see on the left all the chain of thought prompts that we have created. And these are important to make the natural language expressions. So this section demonstrates how we use Gemini's capabilities with chain of thought prompting and long contexts to analyze and explain the similarities and differences between households in a very natural language way. So human-like summaries can be that, okay, your home has used 32% more heating than similar households due to lower outdoor temperature kind of. And I would like to point out that this step can also be seen as a simple augmented generation step of RAG as we pass the retrieve summaries that we have created earlier along with the target summary into a structured prompt. And this is the generation grounded in the retrieved context. Now, putting it all together, this is the orchestration via function decomposition. So here we have all the steps. So first we filter with the monthly data, then we call the embeddings, and then we compute the cosine similarities, we generate the summaries, and then we return the insights and visualizations. So it can be illustrated in a very pipeline fashion as well. And on the left, you see code snippet for this energy comparison analysis definite function, which does all of this in a step-by-step way. So now I will walk you through the visualization. So here you see the visualization, the final output that you have here. So the target home here we have compared is target home 66. And what you see on the pie chart is energy comparison breakdown of different appliances that you have here. And then on the right, what you see is the target here is in blue, and the ones on the red color are top 5 and bottom 5 similar kind of. So you see that you can understand how the patterns look like and how it is like you can now get a good picture of where you are compared to your neighbors or your energy twins, more correct in a more correct way. So what you see here is the target home is number 66 and average of 10 similar homes is 21, which means that okay, your consumption is really high, and you can try to analyze, okay, why is it kind of what is the difference when you compare with the top 5 here, which is similar household size. Then you see that you are much better kind of your target one is 30.8, and then the average of similar 5 homes that you see here is 33, which is reasonably good for the similar household size. But when the household size is much lower, then the energy consumption is much lower for them than you. So you can get kind of these kind of summaries through this tool and code base that we have built. And then, as I said, like we gave this LLM, we have used Gemini LLMs as well to do a comparison summary as well. We asked the Gemini to create a comparison summary. And here, when this is the whole text is the summary that the LLMs has created. So here, what it says is, okay, the target home 66 exhibits a energy consumption of a typical household of 4 during the summer with a consumption of this, and its energy is primarily driven by air conditioning, then lights, then computers, and then TV. So it is able to understand that whole picture and the pie charts and diagrams, and then it is able to summarize it in a natural way. And also it says that compared to its similar neighbors, the target home shows similar total energy consumption, household size, and reliance on air conditioning during summer. So it gives a good summary and insights of how your home is compared to your digital, or let's say, energy twin. So these are some of the blocks of what we have done in the code. And this is a summary of what are the components that we have used here in the first column, what is the GenAI concept and which function actually implemented those ones. So just to summarize, we have a summary generation with a prompt, and then semantic understanding with Gemini embedding functions, vector similarity search with embedding space, and cosine similarity, context retrieval with understanding the top neighbor and neighbor, here it is in this case 5, top and bottom 5, and then natural language explanation using Gemini 2.0 Flash, pipeline orchestration that we have done with chaining and function calls, and insight visualization by using the plots. So these are the functions that we have used in this project. Finally, let AI tell you the energy story. Stop wandering in the dark. Try Watt-Seer Compare yourself. And this is the code base that we will link into the YouTube video as well. And this is the blog where you can find more explanations as well. And this is the team, Harshita Srinivas, Raveen, and myself, Nagavishnukanth Hirklapati, along with our mentor, Suresh Srinivas. So this is the slides that we have prepared. And then this is how the code base will look like. I will not go into detail. You can go yourself in the code that we will share in the links. But this is how it looks like. So at the end, you actually have a space where you can enter, for example, okay, 35 and then 2023-04 in the comments that you are asked to do. And then you get these kind of summaries. So first you get a pie chart, and then the similarity scores, how similar they are to different homes, and then a LLM comparison summary with a reasoning capability as well. And it gives a synthesized summary as well. And then based on that, it creates pie chart, the bar charts as well for different homes. So this is what we have. And then the code and explanations are written also in the blog. So thank you very much for listening, and try Watt-Seer Compare yourself and get out of the dark and explore your energy story. Thank you very much.